We've been asked to sketch the graph of r equals 3 plus 2 times cosine theta, identifying at least 4 distinct polar coordinates, polar points on the graph. Well, I actually want to take a fairly modern approach to graphing this polar function. I definitely want to find 4 exact and distinct polar coordinates, but before I get started, I'm going to take a look at the graph on my graphing calculator. Now, I might recognize this equation as being that of a limacon. But if I didn't, graphing it first in my graphing calculator, which has been set to the radian and polar modes, would reveal that. And from this diagram on the graphing calculator, I'll at least have some idea of, good points to select. And so just from looking at this, I think it's a good idea to pick the quadrantal points. And then I know I'll go a little bit higher and a little bit lower. So at least 4 distinct polar coordinates. I'm going to start with those quadrantal points. So I need a table for some r's and some thetas. And I'll plug in a 0, a pi over 2, a pi, and a 3 pi over 2. Alright, so when I plug in a 0, I know that the cosine of 0 is 1, which makes this 3 plus 2 is 5. The cosine of pi halves is 0, so I know I'm going to get out a 3. Alright, moving along to pi, the cosine pi is minus 1, I'll get out a 1. And then finally, the cosine 3 pi halves is 0 again, I'm going to get out a 3. Alright, so I'm ready to add some points to my polar grid here. So I'll be going out to 5, 1, 2, 3, 4, 5 at angle 0. At pi halves, I need to go up to 3. And when I get to 3 pi halves, I know I'm going to be going down to 3. And here, just out to 1. And that's actually probably enough information with my graphing calculator to go on and add in the rest of the shape. Because what I see here is a limacon that's flat over here, not dimpled. It's not the shape of a cardioid, and it definitely doesn't have an inner loop. But I'm going to go on and add 2 more points, just because I'm curious at what happens in the first and fourth quadrants. So to my table, now a little bit out of order, I'm going to add in what happens at pi over 3, and down here in quadrant number 4, I'm going to add in what happens at 5 pi over 3. Alright, well, the cosine of pi over 3 is 1/2, and I know I'm going to get out a 4. And at 5 pi over 3, I'm going to repeat that value. So let's add in those 2 points. And as always, if I add more points to a graph, I know if anything, I've just made my graph a little better. Alright, so now I'm going to draw in the graph through now these 6 points. And what I realize is here in the first quadrant, that probably should have been just a little rounder through there. And of course, I think it was okay the way it was, but that's a little more accurate based on what I'm seeing here. And of course, if I wanted to make my graph better, I would simply plot more points.